discuss this question, what it is saying. Okay. So basically the question is saying that a scooter is there of velocity 36 kilometer per hour in 10 seconds. That means, and just after the start. So when the object is starting, like basically it start moving, what do you mean by this just after the start, Naisha?
It means the initial velocity is 0.
Yes, initial velocity is 0. That's correct, completely right. So let's write it down, all the things, whatever it is written over here. Okay. So u is equals to 0, right? And here it is, Naisha. The object has gained the velocity of 36 kilometer per hour after 10 seconds, right? So that means this is our final velocity, isn't it? Yes or no, Naisha?
Yes, sir.
Yeah, please unmute yourself. No worries for the whole class. Please unmute yourself. Okay, because when you will unmute, it will take a time. So you can just unmute yourself. No worries. I'll ignore the background noise. Okay, so after that, Naisha, see this thing. Everything is here. The time is given in seconds, but that is the SI unit. Is this a kilometer per hour SI unit of time? Oh, sorry, speed.
I think it's meter per second, but
It's meter per
kilometer per.
second. That means kilometer per hour is not the SI unit. That means we have to convert it into the meter per second. So how do we convert it? We basically multiply 36 with the 5 by 18 factor, isn't it? Yes or no, Naisha? Okay. So this 18 will cancel this 2 times and 5 twos are 10 meter per second. So the speed of the car, a scooter is basically is 10 meter per second. And time taken to achieve this velocity is equals to 10 seconds. Okay, clear, Naisha?
Can we do with the first one? V is
Yes.
equal to u plus 80.
Yes, Naisha, that's completely right. So we have to use the first one because as the question is asking the acceleration, so V equals to U plus 80. And if I tell you one thing, the first equation of motion is nothing but the change in basically the acceleration formula, Naisha. Take U on the left hand side, what would it become? V minus U. Divide the V minus U by T, what would it become? Acceleration, isn't it? Formula of acceleration, Naisha.
Yes, sir.
Okay. Now let's substitute the values. V is equals to 10. Substitute the values over here. U is 0 plus A is need to be calculated into time is 10. Right. That means 10A is equals to 10. Right. So A would be equals to 10 by 10 meter per second square. That is coming out to be 1 meter per second square. This is your final answer, Nash. Is this clear?
Sir, for the velocity, you did 36 into 5 divided by 18. How to convert it
Na-
into?
yes, Naisha. We did it. I've told you once, I think, in the start of the motion chapter. 1 kilometer. See this thing. 1 kilometer is equals to 1,000 meter, right?
Yes,
And
sir.
1 hour is equals to 3,600 seconds. So Naisha, 1 kilometer per hour. That means if I take 1 kilometer per hour, so that means 1,000 by 36, isn't it?
Yes, sir.
Okay. Divided by 3,600. That is meter per second. That means 920 will cancel out and this is 5 by 18. That means, Naisha, 1 kilometer per hour is 5 by 18. So here, how many kilometer per hour is there? 36. That means we have to multiply 5 by 18 with 36 to get the answer in meter per second. Did you get my words now?
Yes, sir. Now I got it.
Yeah.
So,
Please.
like, if you have to convert meter per second into kilometer per hour, what do you have to do?
If you have to convert meter per second into kilometer per hour, then you have to take 5 by 18 on the left hand side. So it would become 18 by 5. So 1 meter per second would be equals to 18 divided by 5 kilometer per hour. That means if you want to convert meter per second into kilometer per hour, that means, Naisha, we have to multiply the meter per second with a fraction of 18 by 5. Okay?
Yes, sir.
That's great. Please note it down and let me know one step. Yes, Naisha. Please try to solve the next question.
I was solving the next question, sir.
Okay, that's great.
Sir, how do you express retardation? Like for final velocity, we say v. So like
Yeah.
for retardation.
Retardation would be denoted by A, but the retardation would be negative acceleration. That means, suppose if the question is saying retardation, that means, Naisha, it's 5 meter per second is per second square is the retardation. That means the acceleration would be negative 5. That's what retardation is. Got it?
So it's acceleration.
Yeah, acceleration, but in the opposite direction. That's why we say it retardation, because it slows
Oh,
down the body.
I got initial velocity is equal to 40
Unit. What is the unit of
meter.
velocity?
1 second, 1 second. Yeah, meter per second.
Medium. That's very correct, Naisha. That's very good. Please try the next one.
second formula?
Could you please repeat?
Do we have to use the second formula?
Okay, so the question is asking that how much time will it need? So I don't think there is some distances mentioned here. So you can use the first formula, Naisha, because the question is asking about the time. So velocity, final velocity is 0, initial velocity is 0.5 meter per second, acceleration is given. So all the three values are given, only the time is missing. So first equation can be used.
Okay, sir.
Yeah, that's great.
One.
Yes, Naisha.
I got 0.1.
That's the calculation. The answer would be 10, Naisha. Let me tell you why. Okay, so you made the calculation right, but the thing is you just get wrong while dividing. So Naisha, let me tell you how to divide this thing. Okay, I think this is the expression that you must have got as well. 0.5 by 0.005. Yes or no? Is that the same expression
Yes.
that you have? Right, that's great. So can I write 5 as 5 by 10, Naisha? 0.5 as 5 by 10, isn't it? Divided by 0.005 as 5 by 100. Can I write this thing or not, Naisha?
Yes,
Right?
sir.
So Naisha, as you can see, this is a double division. So lower fraction denominator will go in the numerator. 5 by 100. And this 5 will go in the denominator of the upper fraction. That is 5 by 10. See this thing. 5 is getting cancelled. 10 is getting 100 is getting cancelled by 10. The answer comes out to be 10 seconds. Okay. So this is the answer. Please do let me know. Is that clear now?
Yes, sir.
Please solve the sample problem 4. Now see, distance is asking in the question. That means what you have to do? Second equation or third equation. So you can see this thing in third equation, there is no time. But in the second equation, that time quantity is there. That means you can use the third one. Got it?
Yes, sir.
Yep, that's great.
So we had to use the third one, right? Or the second
Yes.
one? The
Yes.
third one.
Second one. Second.
Oh, second one.
Yeah.
Sir, is it 200?
200. Yep, that's right. Very good. That seems like now you can handle such kind of question. Okay, do this one. Naisha. Naisha, are you there? Hello. Naisha, am I audible? Naisha, you're not audible to me. Please check your mic.
Sir?
Yes, yeah, are you there?
Yes, sir.
Okay, yeah. Did you get the answer?
Sir, I got disconnected.
I'll check it. Did you get the answer now for the fifth problem?
Sir, I'm not sure. I tried to solve with the last one. So I got the initial velocity as -5.
No, why initial velocity is -5? The body is already moving with a velocity of 10 meter per second, Naisha. And after that, it is stopping. That means the final velocity would be 0. An acceleration is given to you. You have to calculate the time or the distance covered by the body in that phase.
Okay, sir, I'll do it again.
Yeah, please try it now.
Sir, I didn't get it. Can you solve it?
Sure. Okay, yes, yes. Okay, nice. Let's see this thing. See this thing, Naisha. The question is saying that our body is already moving with a speed of 10 meter per second and it is stopping after applying the brakes. That is negative. So acceleration would be negative because the acceleration would be slowing down the speed. That's negative. Yes or no? The acceleration. And we have to calculate the distance covered by the body. So here the time is not given to you, Naisha. You have to calculate the distance directly. So either you have two options. Either you calculate the time from the first equation, then substitute in the second equation. Or you can just directly use the third equation of motion. Okay. Equals to 2 AS. So here, Naisha, see this thing. V square is 0 square minus U square is 10 square is equals to 2. A is zero point 0.5, negative 0.5, isn't it, Naisha? Then it's minus 100 is equals to minus 2 into negative 0.5. What will be the answer? That would be negative 1, isn't it, Naisha? 1 into S. This negative will cancel this negative. S would become 100 meter. Right? So this is the answer. Please do let me know, Naisha, if it's clear to you or not.
Yes, sir, I got it.
Got it? Please try to solve the next one. Yeah, any answer, Naisha?
Sir, could you explain this to me?
This question was easy. You just have to you can say that change the value of the u and v, then you can just get the answer in terms of acceleration.
I changed it to 50 by 9 meter per second and 10
Hmm.
by 3 meter per second.
How did you get 10 by 3 meter per second, Naisha? It would be 50 by 9,
It's,
it would be 150 by 9. Yeah, you can
I
more
might
sim.
have some
Huh?
calculation. I'll do it again.
Yeah, please do it again. Yeah. Yes, Naisha. Hello. Okay, you got the same answer. That's great. So now you just have to use the first equation of motion to get the acceleration. Okay.
I got like 10 by 3 meter per second. I don't know how.
So Naisha, how? See this thing. So you have to convert the 60 kilometer per hour into meter per second.
Oh,
So
okay.
that would be,
Wait, one second.
yeah.
Just one second.
Yeah. Yes, Naisha. Hello.
Is
Naisha, are
it,
you
is
there?
it, hello?
Yes, Naisha.
Is it 50 divided by 3 meter per second?
Yes, Naisha, that is 50 divided by 3 meter per second. But the thing is, I have not simplified more and taken the basically the denominator is same so that I don't have to take the LCM. Right, I can just directly subtract them when I will substitute into the equation. So 150 minus 50 by 9, that would be just see this thing, Naisha, the LCM would be same. So the answer would become 100 by 9. Even if you take 50 by 3, Naisha, the answer would remain same. That is 100 by 9. And after that, you will divide it by 6 as well. That comes out to be 1.85 meter per second. Got it?
Yes, sir. I forgot to multiply it. That's why I was telling 10 by 3. It's because
Ah,
I forgot to multiply it with 5.
No worries, कोई बात नहीं, no worries. Just note it down. After that, we'll move to the next topic, that is graph. Done, Naisha?
Yes, sir.
Okay, now let's move to the graph part. Okay. So basically, Naisha, in this graph part, we're going to study there are two types of graph that we are going to study in this chapter, right? First graph would be your distance time graph, and the different name of this graph is position time graph and displacement time graph. Both name are same. Okay, so if the distance time graph, displacement time graph, and position time graph, both would be, all the three would be same. Got it, Naisha? So first of all, we have to discuss the graph for the two types of motion. First is uniform motion. So what do you mean by uniform motion? When the body travels the same distance in the equal interval of time. Isn't it, Naisha? According to the, you can
So
say the
it's going
definition.
to be a straight line.
Yes, in the uniform motion, it's going to be a straight line, right? And basically, let me tell you, this line is called slope. What it is called, Naisha? It's called slope. And slope formula is y-axis. So whatever quantity is there on y-axis divided by x-axis. So whatever quantity is there on x-axis. So when you will just divide them, so distance by time. What is coming out to be distance by time, Naisha? Formula. Which of the following quantity is
Speed is
represented
equal
by?
to distance by time.
Yes, that's great. So Naisha, this line shows the speed of the body. Got it?
Yes, sir.
That's great. And see this thing. So you can see it's uniform motion. So in this type of graph, the distance is directly proportional to time. That means as the time increase, the distance will also increase as the time being passed. Okay?
Yes, sir.
Second thing is, Naisha, non-uniform motion. So non-uniform motion means, Naisha, when the distance traveled will not be equal in equal interval of time. Suppose that you are on a road and you get stuck in a jam. That means in that jam, basically, you won't be able to move with a constant speed, Naisha, or constant distance, right?
Yes, sir.
It would be different. Sometimes you will be standing in there for 30 minutes. Sometimes you are basically moving with a very small speed, and after that you are going so anything could happen whenever you are basically performing non-uniform motion. So, but the thing would be the distance covered would not be equal. That's the only thing. Okay, that would be sure. See this thing, Naisha. So distance by time graph would be a curved line. A curved line. Okay. So why, Naisha? See this thing, Naisha. In terms of distance and time, this is your what? Isn't it? S is equals to ut plus half 80 square. See, Naisha, this equation shows that time is distance is dependent on time with a square. Did you get my words? So if we draw this graph in context of distance time graph, it would be non-uniform motion. But is this equation is used in uniformly accelerated motion or non-uniformly accelerated motion? Tell me. Naisha, are you there?
Yes, sir.
I was just asking that. Yeah, I was just asking that this equation is used in uniform motion, uniformly accelerated motion, or non-uniform accelerated motion. Hmm? Naisha, your voice is breaking. Please say it again.
Non-uniform.
Naisha, this equation is used in uniform accelerated motion. The question that we have just right now. In terms of acceleration, this equation is uniform. But in terms of distance, as you can see, Naisha, when the object is accelerating, so will the distance cover equal distance in equal amount of time if the body is accelerating, changing speed like time to time? No, no.
I didn't get it, sir. Can you explain that part again?
I was saying, ki, if the body is there and if it's moving with a acceleration, so the distance covered by the body would be different. Yes or no?
Yes, sir.
Right. That's why the distance and time graph of the accelerated motion is non-uniform. It's a curved line. Now, did you get my words? Because the distance traveled will not be equal. It will keep increasing as the time being passed. Yes or no?
Yes, sir.
Okay. Okay. So this is the second thing. So we are only going to study the uniform motion graph, this one, not this one. Okay. So Naisha, let's talk about it. So slope of the distance time graph for a uniform motion is a straight line. What it is basically, it's a straight line. Yes or no?
Yes, sir.
And the slope of a distance time graph is used to calculate the speed of a body. I've just told you. And next thing is speed. Steeper the graph or slope is, and more will be the speed of the body. That means, Naisha, when the body is basically, see this thing. There are two bodies going like this. See this thing, Naisha. They both have covered the same distance. So see this thing, Naisha. When you will basically join the line to the distance portion, they have covered the same distance, isn't it? But time taken would be different when you draw the graph line on its time for the different body, it's time for the red body. Yes or no? So which body is taking less time, red body or yellow body?
The red one.
The red one. That means that this graph is steeper, it's much more like towards the 90-degree,
Yes, sir.
right? So when the slope is steeper, that means away from the time axis more, okay, the more it will be having the speed of the body. Did you get my words? That means steeper the slope of distance time graph, more will be the speed of the body. Okay.
Yes,
Next
sir.
thing is, Naisha, if the body is at rest, what do you mean? That means distance will
The,
remain same as the time is passing. Is there any change in the distance or position, Naisha?
no, sir.
No, that means the body is at rest, right? At rest. Any doubt so far, Naisha?
No, sir.
Yeah, please note it down fast, and this topic would be done, and for afterwards, the same topic will be continued in the batch class. Okay, so please do not miss the class, Naisha. So by the next two classes, this chapter would be over. Okay, that means we have a
Yes,
class on
sir.
Sunday. That is by 25th of May, this chapter would be over.
Yes, sir.
That's great. Please note it down. Then Naisha?
Sir, just 1 minute.
Okay, sure.
Sir.
Okay, Naisha. So please do this one as well. Okay, note it down, and after that we'll just end this class. Okay.
For the third point of the uniform motion, could you read the first word?
Steeper. Steeper.
Okay, sir.